Hello, and thank you for attending our webinar on 5G Edge and AWS Wavelengths. So I'm pretty excited about this. I think a lot of developers are pretty excited about this new technology using edge computing and AWS Wavelengths. Now, I have a couple experts with me here today to talk about it. I have Robert Belson, who's a developer relations and corporate strategy for Verizon. I have Saravanan Shanmugam, who's a lead solutions architect for AWS Web Services. How are you guys doing today?
Doing pretty good, pretty excited to be here.
Awesome.
Doing fantastic. Thanks for having us, Jeremy.
Yeah, no problem. So let's kind of jump right in. What is 5G Edge? What is AWS Wavelength? And why would developers be excited about this? Do you want to start, Robert, with 5G Edge?
Happy to. So I maybe just to quickly introduce myself here more broadly for the audience tuning in here. First and foremost, good morning, good afternoon. Thanks for coming out to learn a little bit more about AWS Wavelength and Verizon 5G Edge. And simply put, for those of you less familiar, imagine having all of those benefits of AWS compute and storage, but at the edge of the Verizon 4G and 5G network, having more choices than ever for where to deploy that application. And I think that's worth noting, ushered in not only by the pandemic, but users' demands for ever increasing immersive experiences. What was good enough today may not be good enough for tomorrow. And payloads are becoming increasingly rich. You may deliver text today, but delivering volumetric video tomorrow. How are you going to be able to deliver those experiences? The current cloud computing environment in many cases may not be good enough. So we teamed up with the Amazon Web Services team here, and I work with Saravanan here pretty much every week to solve these complex customer challenges. But at the end of the day, it's Verizon 5G Edge with AWS Wavelength that enables it, because you take those services that developers know and love and say, well, wait a minute, why can't we bring it way closer to that end user to deliver a much more performant user experience? So we can spend so much more time talking about mobile networks 101 and a little bit more about the architecture, but I'll leave it at that for starters here and turn it over to Saravanan.
Thank you, Robbie. Again, pretty excited to be part of this panel. And just an introduction, my name is Saravanan Shanmugam. I'm a lead solutions architect at AWS. Been with the company for more than 3 years now, leading the efforts of helping customers migrate or even deploy new applications when it comes to 5G Edge. When this journey started almost 4 years back, when we started working with Verizon and other CSPs globally, the idea was pretty simple, as Robbie mentioned. Customers are looking for computes at the edge of the network, either it's mobile network or non-mobile networks. But most importantly, they have a challenge to solve where the latency requirements of certain applications, is very, very, very restricted in terms of what the applications can do within the constraint of certain latency requirements and throughput requirements, like AR, VR, for example, CV2X use cases, for example, which we'll talk about as we move through the questions from Jeremy, is how can we bring the power of AWS services, which was only in the region, right? If you take US, for example, you have 4 regions: Ohio, Virginia, San Francisco, and Oregon. How can we bring these services close to where the data is, where the customers are? And especially when it comes to 5G networks, we know that 5G is a massive change in terms of how data is going to be generated and how many devices are going to be in the 5G network. Can we bring that same services that the developers love and embrace and use every day closer to the data set? That's what Wavelength is all about. In a very simple context, getting access to an EC2 compute or a container engine so that they can run at the edge of the mobile network is what Wavelength is. We have done a lot of heavy lifting in the backend, working with Verizons of the world to see how and where we should position this infrastructure so that it can seamlessly be accessed by application without any heavy lifting on the application development side, and how easily can deploy their application. But on the contrary, everything is abstracted out, right? The developer doesn't have to really worry about how to access these infrastructures. We are building some cool services, which we'll talk about that as well. So at the end of it all, 5G edge computing is such a game changer for so many different applications. and how we can work with the 5G network provider like Verizon and bring the power of AWS services in the name of wavelength close to the edge of the network. So that's pretty much in a pretty 10,000-foot view, but we will go deeper and deeper into explaining some of the concepts as we move along.
And if I could jump in here, Jeremy, maybe just to provide more tangible example for the audience here, let's just talk geography, because that's what we're talking about. There's definitely a relationship between where you are, where your application traffic is trying to go, and in turn, the latency or time it takes to get from point A to point B. It's not a perfect linear relationship, but there's a relationship nonetheless. And so let me give you a practical example. First and foremost, we need to understand that the internet networks are designed as a best effort service, whether we like it or not. And we have to remember that, because at the end of the day, networking is a lot about get what you get and you don't get upset. And by that, I mean, today, as you traverse a network, as you leave one network system and connect to another, you hop across a series of routers. And at any given point, that individual router or traffic juncture could be overwhelmed. And so what happens? Your packet could be dropped, and the initial client could be forced to resend that information. What that means for you? Delay, latency. And nobody's guaranteeing along that journey that it's going to seamlessly flow through. So in the example where you're delivering a really immersive experience for, say, spring break in Miami, that's one such example, maybe a really cool AR application. If you're connected to one of the 4 AWS regions, as Saravana had alluded to, you have to travel from Miami all the way back to Northern Virginia. Actually just did that drive a few months ago from Miami to Northern Virginia. Let me tell you, it's not fun. Similarly, it's not fun for packets either, because you have such a material distance to traverse where you could incur that non-determinism associated with the latency penalties. So what if you could say that same application and that same application infrastructure could be delivered not only within the Verizon mobile network itself, but also within Miami. You don't have to go all the way across the eastern seaboard. It's right there. And so imagine extending that example to all of the different cities we have today, all the 13 cities everywhere from New York City, Miami, Denver, Seattle, just to give you a few examples all across the country. You begin to have this really powerful distributed architecture that the average user consuming an application will know absolutely nothing about by design. But you as the application developer have more choices than ever.
Yeah, and so if I'm understanding it correctly, so if I'm using an application like the Pluralsight app, where I'm streaming a video and, I'm sitting here in Portland and I'm hitting a server in the Dalles in the Oregon zone, and there's this big hop, and that's not really that big of a deal. But when I, like you said, a VR app, or I'm playing a video game and I need that just lightning fast latency, and does that mean that the EC2 server, instead of being out in the Dalles or possibly being in San Jose or something, it's going to be right in Portland near me, like physically near me as I'm playing? Am I understanding that right?
That's exactly right. And I want to pick on Saravana here for a second to talk about a really cool application he built with media streaming and the millisecond clock. It was his invention, so I want to give him credit for it. But yeah, awesome. Worth noting, from an overall, let's say, application design perspective, there are two main ways that you're going to save on your latency budget. First and foremost, if your application is one where it's not just one request, it's many concurrent requests, like a transaction. It's often not just one request, it's a series of requests. And so every incremental request, you're going to save on your latency budget. So the effects compound on top of one another to deliver that best-in-class experience. So that's one such example. The other great example is, of course, when the payload is rather significant. So maybe it's one transaction, but it's a giant video file that has to be streamed to you. By cutting out everything from leaving the mobile network packet core all the way to the internet down to that, let's say, cloud data center, cutting all of that out, you have a much more direct path to stream that video. So those are the two scenarios where you're going to see certainly the immediate performance benefits. But I'd love to call on Saravana to talk about the millisecond clock example, because for curious developers who want to build a little something extra, this is truly the best way to see that performance benefits.
Yeah, absolutely. When it comes to video media distribution and media content production, we have seen a lot of interest from media companies to understand what this technology is about and how they can leverage the power of 5G with the wavelength, which is sitting next to the mobile packet core. So what we wanted to showcase them is how much of latency savings that they can get from a round trip time perspective, as well as from an application round trip time standpoint, right? So we kind of built a very small lab, which kind of showcases that value of 5G edge compute and ultra wideband, because we'll talk about, what are the different 5G implementation out there, and how a C-band, which Verizon is going to implement pretty soon in production, can dramatically change the way the nature of 5G operates inside the country, inside the Verizon's footprint. But long story short, when we talk to media entities and media customers and media broadcasters, they want to see, they are always looking to cut short the latency as much as possible, right? It's not so much about most of the web services. Some of the web services can handle higher latency, some API calls, but it's all about very, very niche use cases, right? Very niche applications, which can really dramatically feel different, right? Which can dramatically feel different when the latency is removed, or when the latency is dramatically reduced. As Robbie mentioned, let's take a media use case, or Jeremy, you mentioned about video streaming use cases and things like that. We are absolutely saying that CloudFront today can handle most of the web streaming, right? The OTT streaming, CloudFront and other CDN providers can handle really well. But where Wavelength such type of architecture really shines well is if you're looking at next generation video streaming, like AR and VR streaming, or 8K streaming and immersive streaming type of an architecture, where your bandwidth that every session requires is almost close to 50 megabits per second, right? You need a download speed of consistent 50 megabits throughput. Getting that from a public CDN is going to be very difficult, right? Because public CDNs are meant for scale, and they're meant for best effort. They're meant for OTT type of an architecture. And if you're playing this Pluralsight video play out, right, it might be that the user's connectivity could be changing between 5 megabits per second, 10 megabits per second, 20 megabits per second, and then it becomes a best effort nature. And because of adaptive bitrate technology, the playout could be from anywhere from a 4K to a 1080p, 720p, 480p. So the user experience at the end of the day is best effort. That's what Robbie was trying to say. You're completely dependent on how well you're connected and how well the network performs given at any given point of day, right? Or any given point of time in a given day, right? You might actually play really well during the non-peak hours, but during the peak hours, you're completely dependent on how the backbone network is performing, or even the network between yourself and the CDN is performing. What we're trying to say is, with wavelength zone, where the packets are never routed out of the CSP's network, right? And you're almost in the same city where your mobile packet core is resident, in that case, you are going to benefit from reduced number of hops. And because of the reduced number of hops, and you're not sharing the shared bandwidth from in the backbone network, you are going to benefit from that. Your application and your user is going to benefit from that. And when you host your streaming service in the wavelength zone, either for a 4K or an 8K type of streaming, not necessarily for maybe 1080p of service, where you might actually be better off serving that 1080p from a public CDN. But as you go into more mature type of use cases, which requires that consistent bandwidth, that's the key, right? Consistent 50 megabits bandwidth for a VR session. Like say you're doing a VR streaming session and you want to really not downplay the quality of the VR session up and down, and you want to stay on 50 megabits per second, you want to provide that ultra low latency effect of a VR streaming, you need to have compute at closer to where the streaming servers are, as well as the network has to be reliable and dependent on that, right? So this is where the combination of ultra wideband, the compute at the edge of the mobile network, most importantly, the consistent throughput that the application requires, right? We're not going to say that every application that runs in the region will benefit from edge computing. Certainly not, right? There's going to be certain class of application which cannot really handle the latency really well, And because of the throughput differences and jitter differences, the application performance can go up and down all the way and eventually affecting the end user experience. And that's the class of applications we really want developers to start thinking and see how the combination of wavelength and ultra wideband networks and 5G can really benefit those type of use cases.
Yeah, thank you. Absolutely. That's awesome. And so if I'm understanding you right, is there an actual separate network with wavelengths? So is wavelength connecting to, a set of IP addresses just like any other AWS service? Or does it have a special way of tying in with like the Verizon 5G Edge?
That's a great question. Now, what we wanted to do is we want to really simplify how we expose wavelength to our customers, to our existing AWS customers and new AWS customers who really want to leverage the power of wavelength at the edge of the 5G network, right? So, when you talk about AWS, it's all about abstraction, right? The power of abstraction, right? When you go to, typically when a customer wants to deploy an application, the first thing that they do is they go to a region, right? They select the region. And once they select the region, there's massive amount of highly available, scalable, reliable compute in the form of availability zones, right? In the form of availability zones. The first thing the customer does is they create a VPC, which is pretty much well known across the globe for any developer who wants to start building applications in an AWS region. And once they build the VPC, the first thing that they do is they create subnets, right? They create subnets, which is mapped to, if you ask me, subnets is such a powerful abstraction, which is giving you that power to start deploying your computes and applications in a highly reliable, scalable network, right? In a data center, right? In a multitudes of data centers in availability zone. We want to keep that same abstraction, right? We want to keep that same abstraction when it comes to wavelength. So what we did was we worked with Verizon and said, can we build our infrastructure inside your network, right? The same EC2 that runs in the region, the same the Nitro hypervisor, which runs and powers the region. We want to bring our own infrastructure, right? Put it in a Verizon's network close to, like Miami, for example, is one location, right? So we went to Miami and we deployed our AWS infrastructure and said, we don't want to expose this any differently than we expose our computes in the region today, which is the abstraction, which is the subnets, right? So as a developer, now you have the power of now creating a subnet, right, in the wavelength zone, right? Creating a subnet in the wavelength zone in Miami, which is still part of the same VPC that you created, which is encompassing the region. And then now you have like magically expanded your VPC beyond the region, beyond that primary region, which is in Virginia. Think of it as a logical extension of that VPC, and then a subnet is running in the wavelength zone. And now, because of that subnet abstraction, technically what that means to our AWS developers is, that's cool, it's just another subnet. Now I can start deploying my applications, right? An EC2 or an EKS containers or whatnot. Now I can deploy a container workload or an application which runs on top of EC2, right? That's how simple and powerful it is. If you go to the console today, anybody who is an AWS customer, they can self opt in, right? Maybe the next question you might ask me is, how do I as a developer start accessing wavelength zone? Is it some special requirements or requests? Absolutely not. Today you can actually go in, self opt in your account to access wavelength zone. The 13 wavelength zones with Verizon today in the US, you can opt in to actually use any of these 13 wavelength zone. All you have to do is create a subnet. And once you create a subnet, you start deploying your application. What that means is, if you say you are a streaming ISV or you're a developer or you're creating an application which serves your customers in a mobile network in Verizon, and typically today, as Robbie mentioned, I'm in Miami and I have a cool AR application targeting some of my customers in a Verizon mobile network. All I have is an infrastructure running in Virginia region where I deploy my AR application, but it goes through a lot of hops and a lot of network connectivity things where my application is completely dependent on how that network connectivity from my user in Miami all the way to the region in Virginia. But now the same developer now gets an opportunity to deploy that AR application on an EC2 instance running in Miami wavelength zone Now they can route the traffic, right? Now they have to find, there's the challenge which we'll talk about. Now, given an opportunity, now they can route that traffic to the application which is running in Miami rather than going all the way to the region. So it's very simple to get started. The same abstraction, the same developer tool sets of EC2 APIs and VPCs and subnets, you can basically get started in a matter of few minutes if you're an existing AWS customer. If you're not, maybe add 2 more minutes for that because you have to create an AWS account and then you can start deploying your applications in any of these wavelength zones.
Yeah, well, thank you for laying that out, because that was actually going to be my second question is, if somebody has an established application, and they've got a VPC set up, they have all of this infrastructure, it's totally brownfield. And then they decide, well, I want something at the edge. Then it's, as you're saying, just basically a subnet. You can pipe it in and have your application, like you said, in Miami, but you can connect back to the big giant application that you already have set up. Am I understanding that correctly?
Yeah, you're spot on. But one thing I want to caution, right? Where customers, on one side, we want to make it simple, abstract it out, use the power. On the other side, we also want to be pretty cognizant of the fact that these distributed wavelength zones are small scale in nature, right? Because we don't want to build an AZ type of a big infrastructure in every edge. We know that it's going to be serving as very set of latency and throughput specific applications. So the instance types availability, like some of my customers like, that's pretty cool and that's powerful. Okay, let me start deploying Lambda functions. Okay, let me start deploying an RDS instance. Let me start deploying a Fargate type of an application, which I already have in the region. I have to kind of stop them a little bit and kind of explain why that is not available today and what are the things that is actually available today in the wavelength zone, right? What we have done is we want to bring the power of AWS to the edge of the network, right? But what we don't want to do is we don't want to bring all those 200 plus services to the edge of the network, right? Because we know that is not going to be needed for the applications that we are targeting, right? We don't want to deploy, is an RDS necessary at the edge of the network? Maybe not, right? Because the latency requirement of certain applications, that's what is targeting, is not necessarily needed to run a persistent database at the edge of the network. Maybe a memory bound database like Redis and Elastic Cache and others, where you have to quickly write some data and read some data as fast as possible because your latency budget that you're working with your application is very, very small, right? So what we are starting off is a very core foundation of edge compute, which is EC2, EKS, EBS, and ECS, right? So you can bring in an application which runs on EC2. You can bring in a pods or containers, which is already containerized. You can use EKS and ECS to run your container workloads, but you can't run Lambda at the edge today. You can't run KVS, right? It's not that we are saying that it will not be available, but it's all about what the customers are asking us and what we can build as we evolve and understand and learn from our customers as we bring in these new services, right? So I have to be very clear in explaining this to our customers. Don't think of like re-architecting your entire application and move everything to the edge of the network. It's all about understanding your own application and see which part of that application stack has to run at the edge and which can still remain back in the region, right? It's all about the power of 200 plus services that is running in the region and the power of all these distributed compute and container pods that has to run in the wavelength zone, because you need certain applications to run at that latency, right? You don't want to run an authentication backend in the wavelength zone, right? That authentication of doing an application authentication within 100 milliseconds and 20 milliseconds may not really matter for certain applications, right? For most applications. But the key thing is, what is behind the application? You're authenticating that user. And what are you going to do after authenticating that user? Are you going to stream a game? Are you going to stream an 8K video stream? Are you going to actually accept data for real-time processing? And all those things, what matters, not the backend services, which is not in the latency path of that application stack.
Yeah, absolutely. That makes perfect sense. It kind of comes down to an engineering question at the
Exactly.
end of the day. Like, do you need that super fast latency for this thing? If not, then don't worry about it. Leave it where it is. And
Yep.
then if the answer is yes, then go for it. Now I know you can't give a whole lot of details, but what kind of projects are you seeing folks building on Wavelength right now? Like what types of projects?
Yeah, Robbie, you want to take it and then I can tag along? Certainly, because we, as Robbie mentioned, we talk more than we should every week because of the fact there's a ton of interest, right? There's a ton of interest, and I let Robbie kind of start along, and then we'll see what those use cases are and what is really the core meat of thing that we're looking at, and what are the things that we are looking for future as well.
Absolutely. Boy, there's too many to choose from, but maybe I'll start with two and see how far we get. The first example I want to provide is building on AR apps you may have seen today, the Pokemon Go's of the world. It's safe to say that when application developers are building that, they know at any given point that it's the same 20 Pokemons that are going to be superimposed on your pane of glass. And so that can be prepared for by way of prefetching those resources. But in a world where AR becomes XR, so it's more of like a virtual telepresence type activity, you can't guess in advance what asset needs to be shared amongst a broader audience that could be anywhere, anytime. Thus, sort of screaming the need for mobile edge computing. And there's this really cool customer by the name of Aetho, A-E-T-H-O, that created an app called Beam. And it's an XR telepresence solution. One of the coolest use cases where it's being used today is in college campuses. For those of you who recently attended school in some capacity or have kids going to school, the college touring process takes a lot of effort, a lot of time, and a lot of money. And then now overlaid with the pandemic and let's say less of an active desire to travel, is a Zoom really good enough to find your dream school? Probably not. So what if from the comfort of your home, superimposed on your phone or VR goggles, you could see the campus, that main university building, football field, stadium, you name it. That's incredibly powerful. Could you do it on 4G in the parent region? Probably. But it's not. This is not a live passive webinar. This is an active collaboration between the individual giving the tour on campus and you receiving those live XR assets. That's why you need the low latency connection, and you don't want to wait 10 seconds for that high fidelity image of that iconic campus building to finally arrive on your device. So they've seen some incredible success with Morehouse College as one example, an HBCU based in the Atlanta area. And I see that as one really, really cool use case of not just like purpose hardware disintermediation, but doing something that quite frankly, you couldn't really do before. So I'd say that's one great example. Second great example I'm super excited about that both Sarvan and myself have spent a lot of time with is the Summit Tech team. Based out of Montreal, they are doing some really, really cool 360-degree live video streaming. And what I love about their use case and the promise of mobile edge computing, perhaps in the world today, you had to choose your use case. Is it live streaming? Is it e-commerce? Is it chat? Is it a video chat or FaceTime derivative? With mobile edge computing, why not do them all at once together? With the bandwidth opportunities, with the lower latency opportunities, what if you could have a 360-degree stream while messaging your friends within the app, while video chatting your friends within the app, and making in-app transactions? You're getting a tour of the latest fashion line of a brand. Well, why not one-tap payments and purchase that very clothing item that you see right from that very application? So the Summit Tech team has been doing some incredibly cool stuff. And so I think the two examples here showcase whatever you could do today, you can do tomorrow, but better, higher fidelity, overlay more complex transactions, have concurrent user engagement opportunities, and just together really usher in a higher fidelity experience across the board. Those are the two examples I'd start with, but I'm sure Saravanan has at least 20 more.
Yeah, absolutely. Summit Tech is one which is a great example of how technology and e-commerce and business challenges can come together and solve some of the, I wouldn't say solve, but enhance the experience of the users who are part of that session, as well as provide them an opportunity to have that immersive experience when they are buying some goods over the technology overlaid on top of it. So if you haven't heard about Summit Tech, we actually did our Twitch session, I think a couple of months back with them, real-time video streaming along with their use cases. You should actually take a look at one of our Twitch session, the final one in our first session. But moving on to other use cases, some of the use cases are real game changer when it comes to edge computing, right? When we talk about CV2X use cases, right? The cellular vehicle to everything type of use cases, right? Where automotives are becoming, a technology toy box, right? It's basically how the cars are becoming, I heard a term called software defined vehicle, right? It's no more a car, it is an SDV where software is basically taking over the car. The autonomous driving is a function of that software, which is actually making the automotive makers think very differently. The next 5 years and 10 years in the automotive space is going to be dramatically different on how we will see the car and what runs in the car and what runs outside the car, right? So there is a lot. When it comes to cars, it's one of the thing about gets me excited about the cars is not just the technology which is going into the car. It's a pure mobile use case, right? Cars are not going to be static, right? They're going to be move. The value of the car is when it moves, not when it's actually stable, right? So when it moves, the inherent nature, the requirement of mobility comes into the picture, right? How well the connectivity changes the game for that software defined vehicle is so very important, right? Manufacturers are embedding as much compute as possible, right? With a lot of high-end GPUs and things like that. There's always going to be an opportunity for the cars to interact in real time with other cars on the road, as well as interact with a mobile edge compute, which is pretty close to where they are in that particular given location, right? So if you really think of it in that abstract, right? Let's not worry about, oh, it's Sidelink is going to replace, because there is another protocol called Sidelink where cars can talk to other cars. They can broadcast in the vicinity of like 500 meters or so. There's a lot of things happening in the Sidelink space as well. But when you apply the edge computing concept along with the CV2X use cases and along with Sidelink, there's plenty of opportunities to see how these automotives are changing and how real-time video streaming, real-time data analytics at the edge, real-time safety protection for drivers and pedestrians in and around the cars, and autonomous driving, for example, safety use cases is dramatically changing the way the value of what 5G and edge computing can bring to the table as far as CV2X use cases is concerned. We have been working with, when I say we, Verizon and AWS, and we have been kind of working with pretty closely in targeting the CV2X use cases and see what's the art of possible, right? We are not going to say that we have uncovered pretty much all the things that is needed for building that software defined vehicle. It's about the ecosystem. It's about the OEMs, right? It's about the CV2X application stack builders, right? We have a lot of great launch partners, right? If you go LG, for example, Harman, for example, right? We have actually working with them and others automotive providers across the globe to see what are they thinking about that software defined vehicle and what is needed in terms of connectivity, in terms of devices ecosystem, as well as in terms of the application stack that runs as part of the wavelength, right? Today, it's just that function of EC2 compute and GPU compute sitting at the edge makes a tremendous rethinking of strategy when you define that software defined vehicle. So in long story short, the CV2X use cases is really encourages me or kind of makes my day-to-day very exciting on top of other use cases, right? AR, VR, and media streaming use cases and things like that. But CV2X is built for mobility, is built for bringing in real-time infotainment. When the car, think about it, when the cars becomes L5 autonomous, right? And you have your kids sitting in the back of the car, and as well as you not driving anymore, what are you going to do with that, right? You need to kind of entertain them and things like that. AR, VR, streaming will become such a key component of full autonomous cars, not just driving and making the car safer, and not about next generation infotainment, which can be run from the edge, right? So there's a lot of opportunities when you think for edge computing, when you think about a software defined vehicle and CV2X use cases, safety and things like that. One more thing that I would like to touch upon in terms of the use cases is industrial IoT, right? We have talked about IoT. IoT is such an important aspect for any applications these days. every device can be called as an IoT device because they're connected to the internet and they're sending data, they're streaming data, and most of it will go to the region and some of it will go to the edge of the network. And why it has to go there? Because of the nature of the data, where you have to process the data in real time and do some inference of that data or some reaction to the data, and then send some value back to the source of the data. Like if you look at Industry 4.0 initiatives, right? There's a lot of use cases under the Industry 4.0 initiatives where a lot of data is generated, and without even referring to the use cases, right? I'll just be very abstract and very high level. There's a lot of data is generated from the sensors, from the cameras, from the PLC controllers, from you name, like a food warehouse or a bottling plant or any kind of plant, right? I talk to all these customers and I learn a lot from talking to them on what their use case is about, what sort of data. And these data are very, very important for them, not only just storing and doing some offline processing, but also doing some real-time processing, right? And that's where I get super excited, not only about Wavelength. And another cool partnership that we announced a couple of days back, I believe, with Verizon, a private MEC edge compute platform that we announced in partnership with Verizon, not just public MEC, not with Wavelength. There's always going to be use case which requires 2 millisecond latency, right? There are use cases, believe me, which they say, I need to do this processing in 2 milliseconds. It's not, the 5G network is not there yet where it can give you air latency of 1 millisecond, but beyond that, there is application processing and things like that has to happen, which kind of gets us in the ballpark of 10 to 15 milliseconds and ballpark range. But there are use cases which requires even sub 10 milliseconds, sub 5 milliseconds, where public 5G with public MEC might not really be helpful for those type of use cases, but private MEC, which actually translates into having a private 5G network in the factory and then having a compute attached to the 5G network to do all the processing and analysis, which can give them in their 10 millisecond latency budget. And that's where it becomes so important to really work backwards from customers and understand what the use cases are in terms of their latency and throughput requirement and solve for the customer needs. Either it could be public MEC with public 5G or a private 5G with a private MEC. There's lots of common, and that's why we didn't stop at public MEC. As we learned a lot, we know that there are class of use cases which needs that private MEC capability, where some use cases like, I can't use the public 5G because of the sensitivity of the data and a lot of stuff that cannot be transported outside the factory premises. There are use cases, right? Customers do have, and that's where private 5G and private MEC kind of really becomes so important.
Yeah, absolutely. I could see a lot of use cases revolving around safety, like you said, with IoT and machinery. 10 years ago, even, if a machinery is boiling something and it's getting too hot, it could be 10 minutes before, everybody who needs to know that information knows it and can do something about it. And so that's one area I could see that sub, like that 2 millisecond time being important to prevent accidents and injuries. And yeah, that's really interesting.
Yeah, I would like to kind of add to that, right? It's not about private MEC or public MEC or region or wavelength zone. It's about understanding what the requirements are. And these technologies are complementing each other, right? Some customers prefer to use private MEC for certain use cases. The same customers are happy to use the function of a public 5G and a public MEC, right? So we shouldn't shoe in a specific infrastructure or a specific implementation for every use case. The idea is to give options, as always we do when it comes to AWS, to the developers, to the enterprises, to the startups, to pick the right set of tools to develop and address their business goals. That's exactly what we're doing when it comes to edge infrastructure and edge architecture. Some use cases, they say, you know what, I don't need any connectivity. I'm just okay with running in a snowball edge devices, right? A completely disconnected type of environment. And we are happy to support that. And we are happy to actually work with them to understand, yes, snowball edge is the right technology, because you have the set of requirements which can be satisfied by snowball edge. I've seen customers who are building private 5G and private MEC on a snowball edge, right? But because that suits their need. But when it comes to bigger, scalable, and pay-as-you-go model type of an infrastructure, public MEC and public 5G will absolutely suit certain use cases. So we have several use cases that we are working on, which can overlap across different spectrum of infrastructure. But that's why it excites me a lot when we announced that partnership with Verizon around private 5G and private MEC and public 5G and public MEC. And I'll also tell you one thing before we move on to the next question is, I've seen customers where they say they love public MEC and the public 5G, and they're happy to actually deploy their workloads. And you have seen that there are areas where these industries are, at this point, public 5G is not available, right? Like ultra wideband, for example, which gives you that ultra low latency and throughput. Ultra wideband is not available where the factories are. So when C-band comes into the picture, or even before C-band, customers are like, I'll go with the private 5G and a private MEC implementation because of the fact that I don't have access to a public 5G in my area, which kind of gives them the capabilities to run their workload in a self-confined environment. But as 5G becomes so ubiquitous, with C-band implementation comes with more coverage and gives the same latency parameters, then customers will have more options than just having only private 5G and private MEC. They can have combination of technologies between public MEC and private MEC, right? So there is plenty of stuff that customers can think through as the technology evolves and matures.
Awesome. Yeah, and could you elaborate a little bit on what the C-band is for those who don't know, just kind of a high level, what that is?
Sure. Probably you want to take it, or that's a Verizon specific question? I would love you to answer, or else I can actually take that question.
By all means, go for it.
Yeah, so I'm not going to pretend I am a 5G expert or from a radio side, but I'll give you a very high level explanation of that, right? So when you talk about radio, the next important thing that comes to mind is the spectrum, right? The range of frequencies that the carriers can transmit data on, so that these devices can lock onto a certain frequency and start sending data, right? Today, when you look at, every carrier has its own spectrum allocated. They go and bid for the spectrum, they buy the spectrum, and they are allocated a licensed spectrum, so they can use the licensed spectrum to send data and to actually serve their customers, right? When it comes to 5G in the US with Verizon, there are two types of 5G, right? One is the ultra wideband spectrum, which is in the 24, 28 gigahertz range, which is a higher, very high spectrum range. And then there is nationwide 5G, right? Today, right? Nationwide 5G, which pretty much uses the 4G LTE band of spectrum in the less than 3 gigahertz space and things like that. What we're trying to do, so there's two bigger pools of spectrum, right? One is the lower band, the other one is the very, very high band, which is the ultra wideband, right? Anytime you do testing today, the best latency and the throughput that you get is with ultra wideband. No question about that, right? Every low latency that we talk about, 10 millisecond, 15 millisecond round trip time to an application which is running in the wavelength zone, or you get 300 megabits of uplink capacity, as well as was close to 3 gigabits and 4 gigabits of downlink capacity, right? Is all from the ultra wideband network, right? And that is the pro of ultra wideband. It gives such a tremendous low latency as well as high throughput. But the downside is it's very, very narrow in terms of coverage, right? You have to be in a line of sight to really get that connectivity and get that power of low latency and throughput. And that's why we see that ultra wideband can have a lot of play, a lot of use cases inside a small venue, right? And in a stadium, for example, in a mall, for example, in an enterprise location, for example, which is pretty much going to give a lot of coverage, a lot of bandwidth, a lot of devices can connect and give you the best and best of edge computing and 5G ultra wideband, right? But the con is you have to have a lot of ultra wideband availability, like a lot of nodes have to be rolled out across the nation. And as you can see, Verizon is doing a tremendous job in making sure that most of these cities, big cities, have ultra wideband, right? But it's going to take its time where ultra wideband is really available across the country, become ubiquitous and provide this level of coverage and throughput, right? What C-band does is C-band kind of sits in somewhere in middle of this low band and the high band. The beauty of C-band is it can spread much longer, like several miles together. And it also has the same functionality, almost the same functionality in terms, physical parameter functionality in terms of latency and throughput, right? What you get, like it's almost combining the power of the low band, which is more reachability, and getting the power of low latency and high throughput from ultra wideband, combining them together to give you something called a C-band, right? Which is in between kind of a spectrum. So we are, Verizon won a lot of spectrum from the last auction, and they're going to implement C-band across different parts of the cities or different cities in the US. That is going to be giving more opportunities for developers and applications to leverage not just ultra wideband, but also C-band. And these devices are capable of connecting to the C-band already. So in that case, I'm seeing a slew of applications would be starting to leverage C-band because of the coverage and also because of the same physical parameters of low latency and high throughput. So keep up with that news. I'm pretty sure Robbie and the team would do a great job of letting everybody know when these cities are being C-band enabled, and more use cases you will start to see benefit from that. Like IoT use cases, for example, industrial IoT use cases, for example, they might actually natively get C-band into their factory floors or in the vicinity of where they are. Now those type of use cases, which was preview to private MEC, can now become a public MEC and a public 5G type of an architecture.
Yeah, that's amazing. Well, thank you for that explanation. That's great. So this is a question for either of you, whoever wants to take it. What if I'm a developer and I want to get into this this type of thing, this AWS Wavelength and edge computing? How can I start? So what's the best way for developers to get started?
Absolutely. I want to start with the Pluralsight answer, and then I'll hand it over to Saravanan to talk about the generalized AWS answer, because at Verizon here, we've been working very closely with the Pluralsight team on thinking about how can we upskill the developer community on something that, while very, very similar to the tools that you know and love on AWS, there are some nuances and challenges that some practitioners and DevOps engineers might want to learn more about. And it's really important to, certainly me, as I think about leading our developer relations efforts here at Verizon, how we democratize access to mobile edge computing knowledge. And to me, Pluralsight was a great way to do so. So we teamed up with many of your teams here, as you very well know, Jeremy, to create not one course, but 2 courses. And so the first place to start is, if you look up, even on Google right now, and you go something to the effect of Pluralsight, Introduction to AWS Wavelength, you'll find it immediately. We worked with Andru Estes, an amazing cloud educator, really telling you everything you need to know about the basics here, the VPC, the wavelength zone subnets, carrier gateway, carrier IP. And what I love about these courses is it's not just hear a bunch of concepts, go figure it out yourself. There's a guided tour of how to use the AWS console to build your first app. And so step 1, I'd say watch that course. It's about 22 minutes, I think. Everything you need to know as a baseline for AWS Wavelength. But guess what? We didn't want to stop there. We wanted to do a little bit more. We're getting a lot of questions from customers about containers. And so who better than Nigel Poulton to author the second course that we're very excited to announce today, all about containers on AWS Wavelength. And so now you can get a little bit more of a deep dive on what's different about the control plane, about your node groups, if at all. Stay tuned, take a look at the course. And there's also another guided lab to get started here. So between those 2 courses, you're certainly well on your way to getting started, but certainly from the Verizon end, we work every week with AWS on building enablement content. It's a great example. Our 5G Edge tutorials GitHub repo on our Verizon official GitHub, great place to find quick code snippets on the SDK, CDK, CLI, CloudFormation, Terraform, you name it. We're just trying to make it really easy to get started, but that's only scratching the surface of some of the opportunities that we've developed. Anything you'd want to add to that, Saravanan?
Yeah, absolutely. It's a great job that, in partnership with Verizon, we're building this reusable templates and pretty much removing that undifferentiated heavy lifting from our customers, developers, that they don't have to deal with manually configuring the VPCs and subnets. It's all the core infrastructure that has to be built, that can be built very automated fashion. using Terraform, CDKs, and CloudFormation, blah, blah, blah. But after that, right, the most important aspect is what are the things that ISVs are building, right? That's another one that we are accelerating. It's about enabling the software developers and the ISVs of the world, the SIs of the world, to look at the customer challenges and connect them together with solving using wavelength zone infrastructure, right? We talk with, for example, MongoDB, Confluent, for example, building Kafka cluster very seamlessly, building WebRTC streaming engines inside the wavelength zone, building CV2X applications inside the wavelength zone, right? So there is a lot of activity going on, not just enabling the infrastructure side of things, but also moving up the stack to see what are the reusable templates that we can build for application developers to start leveraging, right? I'll give you an example. We are working with an automotive customer, several automotive customers, OEMs and tier 1 software providers and tier 2 software providers. And they are leveraging connected car ecosystem that AWS has built. They are also building in their own software ecosystems using AWS managed services and building the connected car platform, the software defined vehicles and things like that, right? There's always going to be distributedness, right? As I said, it's not that the entire connected platform has to run in the wavelength zone. We don't envision wavelength zone running the entire backend components of a connected car. It's about picking the right components of that connected car ecosystem to run in the wavelength zone. So what the efforts of the team that is working together with Verizon is to make sure that all these undifferentiated heavy lifting is taken care by means of providing these reusable CloudFormation templates. And as you start digging into these applications, most of them are using some sort of a messaging bus, some sort of a streaming engine, some sort of databases like Elastic Cache and things like that. But since we don't have those managed services like KVS, for example, or the Elastic Cache as an example, right? We want to see what are the other workarounds that the customers can do for now as they're running the box and taking it to production, how we can actually bring that production equivalent type of architecture by means of building solutions with the ISVs, right? Not just at the infrastructure level, but starting to build that solutions which can be consumable at the platform level, right? It's an infrastructure level and then the platform level, and then finally the actual software which actually runs on top of the platform. So we are trying to focus more around infrastructure and the platform by means of bringing Confluence and MongoDBs of the world, Confluence of the world. There's another customer that we talked to, which actually builds databases along with the analytics engine. So we are trying to bring in as much value as possible in terms of building the real application, the real game changer, and not to worry about building the infrastructure and platform for the developers. So there's a lot more of customers who have actually announced their products on top of Wavelength, like Red5 Pro is an example that I can talk to, where they have announced their availability on Wavelength. Red5 Pro is such a known entity in the WebRTC streaming space. And if you look at media streaming use cases, if you look at a drone-based surveillance, if you look at video analytics, most of them run on top of underlying WebRTC infrastructure, right? If we don't build that enablement, the customer has to build that infrastructure before they can start deploying their analytical software on top of WebRTC platform. What we're trying to do is slow, block by block, trying to untackle or remove that heavy lifting from the customer so that they can leverage the well-vetted out solution so they can target the application that they want to deploy in the wavelength zone.
Yeah, that is awesome. Well, thanks for laying that out. And so we can take some questions now from the chat. If you guys don't mind, we'll see. So those of you who are watching and have a question for Saravnan or Robert, we do have one here. Are there any white papers you can share for future reference? Also, is edge computing compatible to integrate with blockchain technologies? I knew there was going to be a blockchain question. I just knew it.
Boy, you want to start, Saravnan?
Yeah, absolutely. I'll start with the white paper question. We do have solution briefs already. If you go to the AWS product page today, Wavelength product page, we have solution briefs around media and entertainment and industrial use cases and automotive use cases that we have. Solution briefs are very high level. I'll be pretty honest. What we're trying to do is we're trying to start from a very high level, help the customer understand what the use cases we are seeing, what the solution briefs at a high level, and there are going to be reference architectures that we are going to publish pretty soon based on all the learnings around use cases and what the customer requirements are and how you can architect today, right? Architecting today without any managed services possibility is one aspect of it. But as we learn more and more, these reference architectures will evolve and we'll actually have version 2 of the reference architecture and things like that. But great question. We have solution briefs. There are reference architectures will be published for at least 5 different verticals. Keep up with the page. We will actually update that. In reference to blockchain technology, I'm certainly not an expert on blockchain, but I will reference you to one use case that actually got published, as well as they actually won an award. There was a R3 Corda, right? There's a consortium which actually enables developers in the blockchain space. And this company called Parse Data, right? Go and look for it. It's actually got published. There's a company called Parse Data who won the Corda challenge this year, and they built their use case around smart charging and geolocation based validation and things like that. Pretty cool technology using wavelength and blockchain. So using wavelength and blockchain. So it's about tying CSPs around wave edge computing, smart charging, geofencing, and blockchain. It's combination of such a cool technology, and they actually won the Corda challenge. So that's far I know that blockchain certainly can be run on wavelength, but look at that Parse Data as an example so that you can get more details. But we are happy to share additional information working with the blockchain technology team in AWS as well as Verizon to see what are the art of possible of running blockchain specific technology in the wavelength zones.
Awesome, thank you. And so we do have another question from an architecture perspective. What are some gotchas you might want to consider when developing your first app in AWS Wavelength?
I definitely want to take this one. We need a whole other webinar to dive into it, but the following problem statement. You have your maybe 4 parent regions today in AWS. You're going all in on AWS Wavelength, all 13 wavelength zones. But if you recall, your mobile device doesn't typically have knowledge of your infrastructure. It just looks to resolve some general domain name, mycoolapp.com. And then something other than the phone itself, often DNS, takes care of resolving you to an IP address or the location of that application itself. But in AWS Wavelength, we have to remember that these carrier IPs or carrier-facing endpoints are not actually addressable by the rest of the internet. Thus, the tools we know and rely on aren't necessarily suited today for wavelength. What that means is you need another way to figure out what the wavelength zone closest to you actually should be. And here at Verizon, we've been working really closely with AWS to really think about what an edge discovery service might look like. And so today, if you go to our 5G Edge portal, you can get started with the Edge Discovery Service and do all sorts of really cool things, not just, hey, what's the closest AWS wavelength zone to me? You can start to tie all sorts of other things together in really cool ways where you could say things like, well, okay, I know the closest wavelength zone to me should be Boston because my phone's in Boston, but I only have a workload in New York City. So I have 2 options: connect that next best alternative, fail over back to somewhere in Northern Virginia, or instantiate the workload in New York City on the client's behalf. So network intelligence is going to start to play a really, really important role in how you design applications, however that might be. I would encourage you to learn or check out rather our Edge Discovery Service, where you can learn more on our Verizon 5G Edge blog on Medium to start to unpack the gotchas there. I'd say that's one of the biggest areas that you may not think about on day 1, but day 2, oh boy, that's definitely a huge opportunity that we're really excited to continue to lean into.
Awesome, thank you. All right, it looks like we're at time now. And any last thoughts for any of our folks watching? Sarah?
All I would say is it's a journey. When we started couple of decades back, when AWS got started, It's a journey for us to work with the customers, learn from the customers, and build the features that the customer really wanted to build, so that most of our feature sets are driven by customer feedback. That's exactly how I see with Wavelength Zone as well, with edge computing as well. It's a journey working with the customers, working with the ISVs, understanding the use case that really can benefit from running in the Wavelength Zone, and leverage that learning and to build the services and functions that is needed for our edge compute developers. So pretty excited to be part of this journey, talking to customers, learning every day. And I would say, come along with us. We would be happy to learn and educate, as well as build services and features to solve the real business goals and challenges of our customers. So
awesome. And Robbie, did you have anything to add?
Sure. Just
Last thoughts?
want to thank, yeah, of course. I just want to thank everyone for tuning in. We love the opportunities to do things like this. We're always looking for developer feedback. Tell us what you like, what you didn't like, what you liked from the course. Hell, if you finish about 2 of those courses, let us know. We might have an opportunity to feature you on our developer newsletter that we send out once a month. We're always looking for ways to engage with the developer community. So keep us posted. Excited to go on the journey with you, as Saravanan mentioned, and looking forward to the opportunity to come back sometime.
Awesome. Well, thank you everybody for watching. Thank you both for this presentation. This has been awesome. This is an exciting technology that, I feel like we're just at the very beginning of, and it's already this cool. So it's very exciting. And so thank you both for coming in here and giving all this great information. I think it's going to inspire a lot of people to enable that in their AWS console and start going, myself included. I'm definitely going to build some kind of app just to try it out and play with it. It's pretty cool. So thank you very much for that. And thank you everybody for attending our webinar.
Thanks so much, everyone.
Thanks, everyone. Take care. Bye.